Today our topic is linked list. Before learning this video, please consult our previous videos on linked list of this series. We already learned in our previous videos that there are three types of linked list: singly linked list, circular linked list and doubly linked list. We already learned different operations on singly linked list. We already learned different operations on circular linked list. Today we will learn more operations on circular linked list. So today our topic is some operations of circular linked list. So we already learned a circular linked list is a sequence of elements in which every element has a link to its next element in the sequence, and the last element has a link to the first element. That means circular linked list is similar to singly linked list except that the last node points to the first node in the list and the external pointer holds the last node address. So we already learned different operations on circular linked list. Today we will learn more operations on circular linked list. Our first operation is insert a new node at the end of a circular linked list. So see the discussion. Function name is insertEnd, and here also I am passing the address of external pointer or header, that is this 600. So I declare in this way struct node double star ext. Ext is an address that holds another address, that is the address of a node. So ext is an address that is 600. 600 holds another address that is 4000, and 4000 is the address of a node. And int x. X means x is the info of our newly created node. The node which I want to insert at the end of our linked list, that node info is x. See, I give say x value is 44. Now struct node star p star q. P can hold address of any node. Q also can hold address of any node. First I allocate this space using malloc. So malloc allocate at the time of run struct node size memory chunk, and it returns the initial address of memory chunk to the variable q. So q holds this address, initial address of this memory chunk. Okay. So q is the initial address of this memory chunk, and q arrow info is what? Q arrow info is, because it is our newly created node, info is x, that is 44. So q arrow info is 44. Now first case, if our linked list is empty. If our linked list is empty, then external pointer holds null. So if external pointer holds null, we can say our linked list is empty. So how we can check? We can check in this way. If star ext equals to null, then we can say our linked list is empty. So our node, our newly created node is our first node, it is the last node, it is the only node in the linked list. So q arrow info is 44 and q arrow next should be, because it is circular, not linear, so q arrow next should be q. That is, it holds its own address. And what is star ext? Star ext is q, because this is our first node, this is our last node, this is the only node of our linked list. Else, what you have to do? You have to insert this node here, because this is our last node now. So what is q arrow next? Q arrow next should be, because this is our last node, q arrow next should be 1000. From where I can get this 1000? I can get this 1000, it is 4000 arrow next. From where I can get this 4000? It is star ext, value at ext. So q arrow next should be star ext arrow next. Q arrow next should be star ext means 4000 arrow next. So q arrow next should be star ext arrow next, that is 1000 is here. And star ext arrow next means here, because I want to insert this node here, so this is q. So star ext arrow next is q. In this way you can add this node. But remember the sequence. If you first write star ext arrow next equals to q, you can't get this 1000. So first you have to give star ext arrow next value to q arrow next. That is, first you have to give 1000 here, and then you have to give star ext arrow next equals to q. And last thing, what you have to do? You have to give external pointer here, that is in here star ext it is q, because this is our last node now. because this is circular linked list. Last node address is in external pointer or header. So because this is our new last node, so address of this node should be in external pointer or header. In this way, you can add a new node at the end of any circular linked list. Our next operation is delete first node from a circular linked list. See the discussion. Delete first node from a circular linked list. So function name is delete begin. Here also I am passing the address of external pointer or header, that is this 600, and this function returns the deleted node info part, and each node info is integer, so deleted node info part is also integer, so the return type is integer. Struct node star p star q means p can hold address of any node, q also can hold address of any node. P equal to star ext, value at ext, it is 4000. So P holds the address of the last node because external pointer holds the address of the last node. Because it is circular linked list, so this one is P. Now case 1, if empty linked list means if star ext, that is value at ext, if it is null, then just write one printf statement impossible and return -1. Case 2, only one node. How you can check whether your linked list contain only one node or not? You can check in this way because it is circular. P arrow next equals to P. P is 4000, P arrow next is also 4000. And what is P? P is star ext, that is 4000. Then we can say there is only one node and it is the first node, it is the last node, it is the only one node in the linked list. So what you have to do, x equals to p arrow info. So x is p arrow info means 55. I have to return this x. Free p means I have to deallocate this space, and star ext equals to null because after deletion of this node there is no node in the linked list. So external pointer holds null. Otherwise, normal case, I have to delete the first node. Okay, first node means this node. Because see, the last node address is stored in external pointer, I have to delete the node after this node, and this is the first node. I have to delete this node. So this is our P node. P equal to star ext, P holds the address of the last node. Now I want to delete this node. Okay. So Q equals to P arrow next. So Q is the next of P. Next of P means 1000. So Q is this node. X equals to Q arrow info. So what is X? It is Q arrow info, that is 11. I have to return this X. And I want to delete this node, the first node. So I want to delete this node. When I delete this node, P arrow next should be what? It is 2000. From where I can get this 2000? This 2000? It is Q arrow next. So P arrow next equals to Q arrow next. So here I have to give 2000. Free Q means delete this node, that is reallocate this space. So in this way, you can delete the first node from your circular linked list. Our next operation is delete specified node from the circular linked list. I have to delete that node whose info is given from the circular linked list. See the discussion. Delete specified node from the linked list means a particular node info is given, I have to delete that node. So function name is deletex. I am passing the address of external pointer, that is this 600, and the value which I want to delete means that node info which I want to delete. So struct node double star ext means ext is an address that hold another address, and that is the address of a node. So here I am passing this 600. So 600 is an address that hold another address, that is 4000, and 4000 is the address of the last node because it is circular linked list. And here x is, say the x value is 33. I want to delete this node. Struct node star p star q means P can hold address of any node, Q also can hold address of any node. I give P equal to star ext, that is value at ext. It is 4000, that is the last node address. So P equals to 4000. Now case 1, if empty linked list. If the linked list is empty, external pointer contains null, means no node is there, then it is impossible to delete. So just write one printf statement impossible and then return -1. Otherwise, if one node means there is a single node in your circular linked list. How you can check there is only one node in your circular linked list? If that node next hold its own address. See, if star ext arrow next equals to star ext means what? Star ext means what? Star ext means 4000. So 4000 arrow next equals to 4000. Then this is the only node, this is the first node, this is the last node. And also this node info is 33, that is star ext arrow info is x. Means this is the first node, this is the last node, this is the single node, this node info is 33. In this case, what you have to do? First, you have to take this info and store it to the variable y. So star ext arrow info equals to y. So y equals to 33. Then free star ext. You have to delete this node. Then star ext equals to null. After deletion of this node, you have to, no node is there, you have to give here null. Means no node is there. And you have to return the deleted value, that is this y. So the return type is integer. Another case is if our required info is at the last node, means if the last node info is 33 and there are another nodes in our circular linked list, then how you can check that last node info is 33? See, p equal to star ext. First you have to check p equal to star ext. What is p? P is star ext. I already assigned. See here, p equal to star ext, that is p equals to 4000. See here, you have to check here whether p equals to 4000 or not. Yes, p equals to star ext. This is our p. This is star ext. And also p arrow info is x. See, p arrow info is 33. So both conditions are true. In between these two conditions, there is and both conditions are true. P is the last node and also p arrow info is 33. Then what you have to do? Y equals to p arrow info. So what is y? It is p arrow info, that is 33. Now what you have to do? You have to delete this node. If you want to delete this node, here you have to give what? Here you have to give this 1000 because this one will be our last node now. If this one will be our last node, if I delete this node, this one will be our last node, then this node next part contains 1000. So I have to get this node and give 1000 here. So how I can get this node? How I can identify this node? I can identify this node in this way. This node next part is star ext. See, 3000 arrow next, that is 4000, it is star ext. So I start one while loop. While p arrow next not equals to star ext, p equals to p arrow next. So first time p is this 4000, is p arrow next is star ext, that is p arrow next is 4000? No. Then p equals to p arrow next. So our new p is this. Again check. While p arrow next not equal to star ext, is p arrow next is 4000? No. Is p arrow next is star ext? No. Then p equals to p arrow next. So p is this. Again check. Is p arrow next is star ext? Is p arrow next is 4000? No. Then p equals to p arrow next. So p is this. Again check. Is p arrow next is star ext? Yes. P arrow next is star ext now. Now what you have to do? P arrow next should be what? It is 1000 because I want to delete this node. So P arrow next should be 1000. From where I can get this 1000? It is P arrow next arrow next. See, P arrow next is 4000. 4000 arrow next means 1000. So P arrow next should be P arrow next arrow next. So here I give 1000. And I have to delete this node. So delete this node. Free star ext. Star ext means 4000. So deallocate this space. Now star ext equals to what? Now star ext point to this node because this will be our new last node. So this will be our new last node. So star ext equals to p, that is 3000. And I have to return this y, that is 33. Or other node means if 33 is not the last node, it is any other node. So what I have to do? I have to traverse the whole linked list till we get that node whose info is 33 and I have to delete that node. But how I can traverse the whole linked list? In this way, first I start from the last node and I have to check each node info till we get this node whose next is star ext. I repeat, first I start from the last node and I have to traverse the whole linked list and check each node info till we get that node whose next is star ext. So what should be the condition? Condition should be while p arrow next not equal to star ext. So first time I check while p arrow next not equals to star ext. Is p arrow next is 4000? No. Is p arrow info is x? Is p arrow info is 33? No. Then come here p equals to p arrow next. Now the new p is this node. Again check. While p arrow next not equal to star ext. Is p arrow next is star ext? No, it is 2000. Is p arrow info is x? Is it 33? No. Then p equals to p arrow next. So p is this node. Again check. While p arrow next not equal to star ext. Is p arrow next is star ext? No, it is 3000. Is p arrow info is x? Yes, it is x. So I get this node. Now I have to delete this node. But when I delete this node, before this node here I have to give what? 3000. Means 1000 arrow next means next of 1000 I have to give 3000 because I want to delete this node P. So how I can get this node address? How I can give here 3000? So I start one while loop. While q arrow next not equals to P, q equals to q arrow next. See, first time what is q? Q equals to P. First time this node is also q node. While q arrow next not equals to P, q arrow next is 3000. Is it 2000? No. Then q equals to q arrow next. So our q node is now this node. Again check. Is q arrow next is P? Is q arrow next is 2000? No. So q equals to q arrow next. So q is this node. Again check. Is q arrow next is 2000? That is q arrow next is P? No. Then q equals to q arrow next. Q is this node. Again check. Is q arrow next is P? Yes, q arrow next is P. So I get that node address which is before P node. The node before P node, I get that node address. So this node is Q node, this node is P node. Now I have to delete this node. So what I have to do? Q arrow next should be 3000. From where I can get this 3000? It is P arrow next. So I want to delete this node. See, I want to delete this node. So Q arrow next should be P arrow next. So 3000 is here. Y equals to P arrow info. So Y is P arrow info. Y is 33. I have to return Y and I have to free this location. So delete this node. Now see, this while loop will execute till the next of P not equals to star ext. But if it is equals to star ext means if 33 is here, means if 33 occurs before the last node, means if this is the situation, if this node is the last node and 33 is before the last node and I have to delete this node, then this is another case. Now if 33 occurs before the last node, means this is the last node. Before the last node here 33 occurs. The info of this node is 33. Then see, this while loop execute till p arrow next not equal to star ext means till this node. Here see p arrow next not equal to star ext. But for this node p arrow next is star ext. So this while loop false. Then when this while loop false, when the value of p is this, then this while loop false because here p arrow next equals to star ext. Then this is the case. You have to write the same code also for this node. If p arrow info is x, is p arrow info is x? Yes, it is 33. Then what I have to do? I have to delete this node. If I want to delete this node, the next of 2000 here I have to give this 4000. Because when I delete this node, the next node of 2000 is 4000. So how I can get this node address? I start another while loop and I have to get this node address. So first time Q equals to P. So this is our Q node also. This is P, this is Q. P and Q both are 3000. While Q arrow next not equals to P, is Q arrow next is 3000? No. Then Q equals to Q arrow next. So this is our new Q now. Again check. While Q arrow next not equals to P, is Q arrow next is 3000? No. Q equals to Q arrow next. So our new Q is this. Again check. While Q arrow next not equals to P, is Q arrow next is 3000? No. Then Q equals to Q arrow next. Again check. While Q arrow next not equals to P, but see Q arrow next equals to P, that is 3000. So I get the node before P node. Now what I have to do? Q arrow next should be P arrow next. So P arrow next is what? It is 4000. 4000 should be here because when I delete this node, then 4000 should be here. So Q arrow next should be P arrow next. So it is 4000. Y equals to P arrow info. P arrow info means 33, that is Y. Free P, deallocate this space and return Y. You have to return the deleted node info, that is 33. So C program to implement following operations of circular linked list. First, insert a new node at the end of circular linked list, delete the first node from the circular linked list and delete a specified node whose info is given from a circular linked list. See the program. So this is our program. This is node structure. These are required prototypes. First one is insert end to create the linked list. Second one is delete begin to delete from the beginning of the linked list. Third one is display to see the whole linked list. And fourth one is delete X means delete a specified node whose info is given by the user. Delete that node from the linked list. Now see, this is our main. Here I give external pointer as null because initially no node is there. So external pointer holds null. So I declare in this way struct node star extptr means extptr holds address of any node and initially it is null. This is one index. I start one do while loop. Do case number 1 is insert end, case number 2 is delete begin, case number 3 is delete specified nodes whose info is given, case number 4 is display, case number 5 is exit and 6 defaults. Take the choice from the user. Here I use switch case control statement. Switch choice. Case 1 is insert end. Take the number of nodes user 1 to insert, then start one for loop for I equals to 0, I less than n I plus plus, take the info of a particular node and call the function insert end by passing the address of external pointer and the info. In this way, repeatedly call inserted function and add a new node at the end of our circular linked list. Case 2 is delete begin. Here also I have to call delete begin function by passing the address of external pointer or header and this function returns the deleted node info part and I print the deleted node info part. Case 3 is delete a particular node whose info is given. First, I have to take which node user want to delete, say it is NO, then call the function deleteX by passing the address of external pointer and the info which the user want to delete. Means and the info of that particular node which the user want to delete. And say this function returns the deleted node info, say it is Y and I print Y. Case 4 is display. Call the function display by passing the address of external pointer or header. Case 5 exit and default case. Now these are our functions. This is display function. We already discussed in our previous video. This is delete begin function. We already discussed in this video. This is inserted in function. And this is delete X function, means delete a particular node from the circular linked list. So when I run the program, see, supply your choice. First is insert end. Case number 1. How many number of nodes you want to insert? Say it is 5. Supply the info part of the first node. Say it is 11. Then second node. Say it is 22. Third it is 33. Fourth it is 44. And fifth it is 55. Now we want to see the whole linked list. Case 4. Display. This is our linked list. Now delete begin. Case number 2. I want to delete the first node from the linked list. Case number 2. So the deleted node is 11. Again I want to see our whole linked list. Case 4. See, this is our linked list now. Now delete specified node from the linked list. I want to delete the node 44. Okay. So it is case number 3. I want to delete 44. After deletion, our linked list is like this and the deleted node is 44. And case 5 is exit. So this is your programming assignment. Write a C program to implement following operations of circular linked list. Insert a new node at the end of circular linked list. Delete first node from a circular linked list and delete specified node whose info is given from a circular linked list. For getting more and more updates, please like, share and subscribe my channel. That's all for today. Thank you.